Thank you to Shandy and Tim. Really excited to give you all a talk tonight. And I think I'll talk about the Elwha Dam removal tonight. You know, I was thinking about going over a recent paper that I published, but I figure that we've all had enough bad news in the world recently, so let's have a little more uplifting talk today, and I can come back at another point here sometime over the course of the next year and give the talk on the changes in run timing and abundance for winter steelhead. So we'll talk about the Elwha today, and for those of you who don't know, and Shandy mentioned, I had been working for Trout Unlimited the past 8 years, and I recently took a new job with a group called the Conservation Angler. A very small group. It's going to be myself as a scientist working with about 3 lawyers. And so part of it is you end up getting a little frustrated after 30 years in the business of seeing us nibble around the edges a little too much. And I felt like with the collapse of our steelhead runs in the Skeena, Columbia, across much of the North Pacific, maybe it's time to be a little bit more aggressive. But the main reason I took this job was, up until very recently, the conservation angler has been leading and doing science work on the last pristine, truly wild populations of steelhead that we have left over in Russia on the Kamchatka Peninsula. And I was supposed to go over there this summer and spend 2.5 months in that field camp working with scientists from Moscow State. Now with the Ukraine issues and Russia's bad behavior, that is not going to happen this summer, which sucks. So, but nonetheless, hopefully by the end of next summer, you know, I'm there. So in any case, at some point in the future, I'll have some cool stuff to talk about with Russian steelhead, hopefully. Before I get into any of the results today, the first thing I always want to mention when I give this talk is literally I might be the one that's presenting the results today, but this has really been a team effort. You know, Lower Elwha Clallam Tribe, NOAA Fisheries, National Park Service, USGS, U.S. Fish and Wildlife, WFW, Bureau of Interior. There's just been a lot of people that have come together, scientists, technicians, policy people that are out there collecting data to help us answer these questions. So when I talk tonight, I'm just one voice literally standing behind an army of people who have done a bunch of good work. And so tonight, my focus is, my interest in the Elwha is mostly the fish. I'm very interested in geomorphology and river dynamics, but I love animals. And so that's why I became a fish biologist. And so we're going to talk a little bit about kind of what has happened since dam removal, and I'll focus mostly on steelhead, coho, and chinook. We'll talk about how far upstream they've made it, how many fish there are, and we'll close talking about summer steelhead, and then a few of the kind of non-salmon related findings that we have that I think are cool. So for those of you who aren't familiar with the Elwha, this is a map. You can see on there where the former Elwha Dam and Glines Canyon Dam were located. River Mile 5 and then River Mile 13. Neither of those dams had fish passage. So because of Elwha Dam at River Mile 5, basically 90% of the accessible anadromous habitat was blocked. And that resulted in a reduction of steelhead and salmon by about 98%. So it was basically a wholesale collapse after having the dams in for a little over 100 years. This is a photo of the Elwha Dam prior to removal. On the right-hand side, you can see kind of a figure that displays how much sediment was stored behind the dam. And it was a lot. You know, there's the Empire State Building and there's an Olympic track, so it's almost 5 million cubic meters of sediment behind it, but it's not nearly as much as we had behind the dam further upstream. But this is what it looked like after the dam was completely deconstructed in 2011. And here's Glines Canyon Dam, much taller, storing a lot more sediment, basically about 3 times the amount of sediment behind it that Elwha Dam was stored. And here is a picture of it deconstructed in 2014. And so one of the kind of cool aspects of this was, this is a transect where Amy East and other geomorphologists basically took pictures and measured the substrate size. And so in September 2011, this is down by the mouth of the Elwha River, and these are all pictures of the same exact plot. That's before dam removal in September 2011. April 2012 is during the process of dam removal. You can see how all of that coarse cobble kind of filled in with a bunch of sand and mud. And by, August 2012, we're already starting to see what we call a coarsening of the sediment. That is, you're starting to transport out that really small, fine sediment stuff, and you're leaving behind more pebbles and other kind of normal size sediment. So that, that's 10 years ago now, but that just gives you a sense of how rapidly the river was transporting that sediment out that was located behind the dams. It was occurring pretty rapidly, and it kind of looked like a moonscape. This is a photograph of the Elwha River above Elwha Dam, where former Lake Aldwell was. So this was the old lake bed, and basically they came in before they built the dams and logged all the forest, but it was a lot of mud basically draining into this. What it reminded me of, in fact, is as a kid, I grew up about 35 miles from Mount St. Helens as a crow flies, and so it reminds me of post Mount St. Helens Toutle River. That's kind of the look it gives you. And of course, this was really hard on the fish, right? We got suspended sediment loads up to levels that were comparable to some of the areas, that were not directly impacted by the debris flows that came off St. Helens, but we're talking the sediment loads were much higher than we would see in a normal debris flow. So it was hard on the fish. We estimate that about 95% of the juveniles and 95% of the macroinvertebrates that lived in the river below the dam died during dam removal. I'm not sure if this video is going to play, but this is a picture here. We'll try and get the video just showing how the river is starting to erode all that sediment that accumulated behind those dams. And so all this sediment up here was basically under a lake bed. But does this play for you, Shandy? Can you see the video playing?
Yeah, yeah. Little.
So,
bladed.
a little sketchy. Yeah. But you all get the gist of it, which is this is during a flood event. It's coming down and it's just kind of eroding all of that sediment that had been stored behind the dams, and trees were kind of falling in like crazy. So it was pretty fun to watch, but it wasn't just that it was eroding things. One of the other things we began to realize is that out here on the floodplain were all these old stumps that had been logged. You can still see the buck marks, the buckboard marks in them, and these things were kind of fossilized. They looked like they'd just been logged the other day. And what we didn't account for was that all of these old stumps might actually contribute to habitat complexity, helping us form pools and riffles on these old lake beds and also helping collect more wood. So this was kind of a surprise. We didn't know those stumps were there because they were all buried under all of the sediment. And of course, after winter, you come back in summer and it's really dry and cracked. It looks a little bit, like one of those shots out there from the Death Valley. So it went through these extreme transitions, really muddy, really wet, then having everything dry. But fortunately, what we did find was that these big old stumps collected a tremendous amount of wood, and they really helped improve channel dynamics and habitat formation for salmon on these old lake beds. And this is kind of a broad shot there of what it looks like. So it looks very different now. Some point I'll put together a presentation that kind of walks people through, 12 years of dam removal. But the point is that this is all lake bed. Those stumps were initially, before the dams were out, they were all covered by about 10 feet of sediment. So the river took all that 10 feet of pretty soft sediment off and moved it out within basically one flood, and then started cutting down through the channel to excavate down to these stumps. And so the question that people have often had is, well, boy, what did the fish do during dam removal? That must have been pretty tough. And it was. But we had a couple of tributaries in the middle river between the two dams where we got to move fish into tributaries that were not directly impacted. So we did relocate some adults, but we also had a little creek that comes out of the hatchery in the lower Elwha. And you can see in the picture here, there's a female steelhead spawning down there in that circle. And so basically what happened is that most of the steelhead and other fish, as they needed to seasonally spawn, they were all kind of pulling into this little creek and spawning there in quite high densities. And that was okay for us because that allowed us to then capture the fish with seines and then relocate them upstream to these tributaries where they didn't have to deal with the sediment. But another cool part of the sediment was, even though it resulted in kind of this really rapid death and destruction of a lot of life within the river, in about 2 years, actually I should say 3 years, we had a very large delta form at the mouth of the Elwha that was not present before dam removal. And this is, again, was, at least to me, unexpected. I didn't think a lot about the river mouth, but we've got a large delta. It's created a lot of this kind of intertidal habitat that's very important for juvenile salmon and other species like eulachon, but also birds. And so it's been really fun. And the surf break for those people who surf is way better there now than it had been. So that's the other cool part is, you know, dam removal doesn't just help the fish, and those of us who love that, you know, the surfers are up here in droves. So that's pretty cool to see too. And so here we are with a picture about 9 years after dam removal. And again, this is one of those areas that have been covered under a lot of water, and you can see how all the wood is starting to really shape the channel and store gravel. And then if you remember those stumps, you know, I spend a lot of time out there underwater. And so here are adult Chinook. Basically every species is now out there on these old lake beds, kind of hiding under those old stumps. So the stumps have not only created habitat, but they're also providing shelter and cover. But the big question is, well, that's all cool. What's happening above the dams, right? Because the whole goal is to get these fish up to this habitat in the national park that is basically in pristine condition. This is Geyser Valley, located about 9.5 miles above the uppermost dam. This is pristine habitat, really never been touched. And so there was kind of a different process for all these fish. A little explanation needs to happen. So for winter steelhead and coho salmon, they're both hatchery and wild fish. But for the coho, they're mostly hatchery because the dams were in place. There was not enough habitat in the lower river to really support an all natural population of coho. So basically what we did was the year before the dams came out, and then during dam removal, and for a couple years immediately following, we started relocating adult coho salmon up into tributaries and the main stem Elwha. We fitted some of those fish with radio tags so we could track them. But the gist of it is that not all the fish that were initially seen up there spawning and using habitat got there volitionally on their own, right? We did move fish to give them a head start. Now, the steelhead were a combination. Almost all the early steelhead we moved were wild fish. We have a broodstock hatchery program. And once those adults started to return, then we started to also move some of those fish. All relocation ended in 2018. And since then, it's been all natural colonization. And so basically the way we're measuring the response of salmon to dam removal is we're using red counts in areas where we can actually count reds because the water's visible enough, you know, clear enough to see them. We're also using snorkel surveys to do the same thing, to count juveniles and adults. And we're using radio telemetry, as I mentioned earlier. And so this is a photograph of two wild winter steelhead. You can see there's a radio tag on the back of each of these fish, and they were being released into a small creek. And here are three steelhead. The one in the middle was actually one of the very first natural colonizing fish that we saw making above the dams. And kind of a cool story is the tribal fella that I work with is also my best friend. His name is Ray Moses, and him and I spend a lot of time out in the field. He's Nez Perce, his wife is Elwha, and so we're out here. We moved a bunch of steelhead up, relocated them. About 2 days after we did the third or fourth relocation, we saw a large male steelhead, about 17 or 18 pounds, move in and was mating with females that we had moved. And we knew that we hadn't moved a male that large up there. We would have clearly noticed it. But the point is that by moving females around, females discharge ovarian fluid. Other males can smell them from several kilometers away at minimum in a river. So it's likely by relocating adults, we were able to stimulate males to basically follow around the females. So not much different than high schoolers. So again, how far upstream? You know, a lot of the same methods again that I talked about there. So we have steelhead on the left and coho map on the right. And with steelhead on the left, I believe I'm using red to kind of show you how far upstream they've made it. And I think with coho, I'm using blue. I'm really colorblind, so forgive me if I'm wrong. But on the left, this was after the first year, right? So this was how far the fish had dispersed after the dam was open and after we had moved fish. And what you see is that steelhead made it, this is the former dam site for the former Elwha. Here's Glines Canyon. that was not passable. Glines Canyon was not passable until 2015. So in 2011, as far as they could go was up into Indian Creek, Little River, and then they could make it up to Glines Canyon. You can see the steelhead distributed, maybe another 9 or 15 miles of habitat. But the coho in the first year of recolonization basically took advantage of almost all the habitat that was available. They quickly expanded their distribution, even more rapidly than steelhead did. So that was kind of interesting. We go to 2013, which is year 3 after recolonization. You can see here that we've got coho a little more distributed into another creek that runs off to the left, and steelhead now are basically at the same distribution by year 3 as the coho were in year 1, but they're about even now. And then we go to 2016. So by 2016, Glines Canyon Dam was passable, and you can see that we've got steelhead now that have made it way above Glines Canyon. But the coho are still petered out, right? They kind of made a glorious first run, and then their distribution didn't increase too much. But one of the most important things here is that initially Glines Canyon, even though it was deconstructed in 2014, was not passable because the dynamiting and explosions left behind big rocks, and those rocks created a barrier to movement of fish trying to get by them. They blew that up in 2015. Here's a great shot of that by John Gussman. Thank you, John, for that shot. And after that, boy, did fish start moving up. So what we can see now here is 2020, 9 years after dam removal. The coho have made it a little bit above Glines, but not that far. But we have summer steelhead that have basically penetrated as far into the upper Elwha now as we think they're ever going to go. So we have fish that are all the way up to basically what are barriers, at least for steelhead. So that's been a lot of fun to see, is that within 10 years, we basically got steelhead back up into places where they hadn't been in 100 years. So I think, it highlights, one, dam removal can have a short period of difficulty for the fish, but man, can they recover fast if things are done well. And this is just to let everybody know, the Elwha has been closed to fishing since 2010, right? So there's been no fishing in the river at all. And I think a lot of us believe that's been a really critical component of this, is just kind of taking a step back and letting the fish do what they want. So this is a similar figure, but it's for Chinook salmon. And again, it just breaks it down by the same periods: 1 year after dam removal in 2011, 3 years in 2013, and then now 2029 years. And so Chinook have not made it as far upstream as steelhead, but they've made it further upstream than coho. And so the other question is, well, how do we actually count the fish? Because we had a lot of sediment in the river, and the Elwha is glacial, which means that red counts can be difficult. Snorkel counts aren't always feasible. We have a sonar in the river. We've been running sonar since 2009, I think, with Keith Denton. And sonar has worked really well. Here's where the sonar is located, basically about river kilometer 1.2. So it's right down at the mouth. We actually have 2 sonars because the channel is split into 2 channels down there. And both those sonars run basically, 7 days a week, 24 hours a day during the whole season for steelhead and for Chinook salmon. And we've got some sampling techniques that we've developed to determine what the ratio of different species are. But it's not that complex. We run the sonar, and this gives us a sense then of how many fish. And so on the left axis over here, that's the total number of Chinook, and on the right axis is total number of steelhead. I'm too colorblind to tell these things apart, but I'm pretty sure steelhead is red, and I can't tell what color Chinook is. You get the point. Oh, you're going through the 90s and 80s, and then as soon as dam removal 2012, you see all these much larger run sizes. And what is really cool is that 2021, which was last year, we had the largest winter steelhead run size on record so far in the Elwha, which was about 2,500 adults. To put that in perspective, that was about the same number of fish as the Hoh River got last year. It was far more than the Bogus Shield got. So again, within 9 to 10 years after dam removal, we're starting to see a nice, really rapid response. These are the Chinook salmon. Now, the Chinook salmon here are a little bit different because most of our Chinook salmon, of course, came from a hatchery population, while the winter steelhead and the summer steelhead, while the winter steelhead had some hatchery fish, there was a naturally spawning wild native population of winter steelhead below the dams that existed. And we had tons of rainbow trout above the dams that could have harbored genes that would resume anadromy once the dams were out. But the point here is, again, just as the Elwha Dam is removed and Glines Canyon is removed, right, we're starting to see these kind of positive responses where not only are we getting more fish, but as you see, we're getting more fish further upstream. Again, just a similar figure showing how steelhead have responded. So one of the interesting things with Chinook is that because they are hatchery, and hatchery fish almost universally survive at much lower rates in the wild than wild fish do. You know, when you start planting a large number of hatchery fish and want them to take off on their own, it's going to take a while for nature to select and operate on those fish. And so what we were seeing basically is that total juvenile production of wild, naturally produced Chinook salmon was really low until 2019. And I don't have 2020 and 21 on here, but they show very similar numbers to 2019. And so what we think happened is that survival was quite poor for those hatchery Chinook, partly because they've been domesticated, but also partly because they were spawning in the main stem river mostly, and mostly below one of the two dam sites. So they were spawning in the old lake beds, and those are really dynamic channel areas. So we would expect as the river stabilizes, which it is starting now to do, we're at background levels of in-stream sediment, so the river is running as it would be before the dam without any dams in. So that's nice to know. So basically, as the river is beginning to stabilize, we're starting to see natural production of Chinook increase. So that's another positive sign for us. And this is just a figure showing the number of steelhead smolts, and we've got different traps and estimates in here. I wouldn't get too much into that. The point is that steelhead smolts are notoriously very difficult to capture in smolt traps, especially in main stem rivers. Those are really large. They're about 8 inches in size, and they can just swim around and easily avoid a trap. So efficiencies are low. That's why those error bars around the little estimates are so big. That's what those vertical bars are. That's the error that we have around our estimate. But the point is that the natural production of steelhead smolts is increasing just like it is for Chinook, and that's another good sign. And so here's kind of the suite of all three species and what you've seen since the first year of dam removal in 2011. I think we're here to 2020, at least in this figure. So things are looking good. But it's not only the adults that are helping us get from kind of point A to point B. These are juvenile Chinook. There's a juvenile steelhead, juvenile coho. And so Little River is one of our intensively monitored creeks that we spend a lot of time in. And we do a census of all the reds in the creek each year, doing red counts. And then we do a census in the summer, come back and do a snorkel survey to count the juveniles. And so here we broke every reach down into basically a 100-meter reach. And what you see is that is where we counted the reds of adult coho. And then what you look down below is this is where we counted the juveniles, right? So there's a bunch of gaps in between where the adults were distributed, right? And then as juveniles begin to disperse, they fill in those gaps. So more of the habitat gets utilized by the juveniles than by the adults. But importantly, we're seeing this in the main stem too, is that, in other words, this means that even though you might have had a few adults spawn in one location in a creek or a river, that their juveniles have the capacity to disperse quite a long ways, hundreds of meters to a few kilometers, and still have their survival be relatively high. So that's kind of been a fun aspect of this. But I think the most exciting aspect of this for me has been the resurgence of wild summer steelhead. And here on the left, we have Eleanor Chittenden in 1907 with about a 13-pound wild summer steelhead from the upper Elwha caught on a fly rod. And then on the right is the very first summer steelhead that I saw make it above any of the dams, and that was October 2012. And I was fortunate enough to have my camera with me that day when I saw that fish. So before the dams came out, there were very few summer steelhead. They were basically almost an extinct life history. Now, below the dams, we might see one or two each year. Sometimes they were clipped, likely strays from somewhere else. Other times they weren't. But again, we knew that we had thousands of resident rainbow trout above the dams. And there's a tremendous amount of research, as as folks probably know if they've heard me talk before, that rainbow trout and steelhead, same species, they can give rise to each other, right? And rainbow trout can give rise to steelhead, and we've got a number of examples of that happening in the literature. So the cool thing is, in 2016, the Park Service went up and they counted like 20-something or 30 steelhead, and then the next year we expanded the survey a little bit more, counted like 60. In 2018, we decided to do a full riverscape and counted like 230. In 2019, I don't have the last years on here. In 2019, we got to like 330 steelhead counted in our snorkel survey. And the important thing is that we use, in 2019, and since we've been using mark resites, so we're capturing steelhead in the lower river with seines and then tagging them with float tanks. So we can do mark resites so that snorkelers go through and they tell us and record the number of fish that are marked and seen, and those that are unmarked and seen. And that allows us to model or estimate population size, because these are just the raw snorkel count numbers. They don't tell us about how many fish are actually there. And one reason this is important is that there's a 5-mile section called the Grand Canyon that we're not allowed to snorkel on the Elwha. It's considered too dangerous. It's class 5 whitewater for kayakers, so it's a really a tough place to be. At some point, I'm going to get in there and snorkel some of it. But the point is, we can't survey all the habitat in the upper Elwha. But again, just to let folks know how hard it is, we have to hike about 15 to 30 miles into the upper Elwha using pack mules and everything else. And then we're hiking anywhere from 3 to 10 miles in a day to do these surveys in water that's about 48 degrees. So it's, you know, it seems like a kick in the pants, but I can tell you at age 50, it is not that easy to hike in 17 miles on the first day and go up 3,000 feet in elevation, you know, carrying all your gear. So what we have here, and I'm sorry, this is a little skewed, this is our population estimate going back to 2019 when we had the 300 fish. This is what the 300 fish actually means when we plug it into a model and account for all the fish that we didn't see. The bottom is a binomial model. The upper one's a hypergeometric. They both work well. I tend to prefer the binomial model. Regardless, the point is that within 4 years of that upper dam being removed, we had almost 1,000 summer steelhead in the upper Elwha. That is more summer steelhead that year than we had on the entire Olympic Peninsula combined. You can add up all of those. In fact, it's probably now almost certainly the largest single wild population of summer steelhead that we have anywhere in coastal Washington. That we can get that response. Now, the numbers recently have declined. We've had bad ocean years, but we also think that this is pretty normal for fish to go through ebbs and flows early in their colonization process as they're trying to figure out which life histories work. So last year was a really low count for us. The population was probably back down to around 200, you know, fish or something like that. But this is, again, part of that normal process that these fish go through. So the big question, the cool one is, where are these fish coming from, right? Where are those summer steelhead coming from? And so summer steelhead have a gene that we call GREB1L, right? And I'm just going to refer to that as the summer steelhead gene. And if you're an individual and you're homozygote for that gene, which means that you have 2 pairs that are dominant, then you are a summer steelhead. You have no say in the matter. Your genes control that. Now, if you have one of those genes or none of GREB1L, you're a winter run. And so what we saw here is that indeed the summer run adults that we were sampling have the summer run genotype, right? These fish that are coming back. And the winter runs that we're sampling mostly have the winter run genotype. Now, some of the winter runs we sampled had summer run genotypes, and this is because we're using time of year to tell us about when the fish are sampled. We're also catching, so some winter steelhead enter in June and July for us, and some summer runs do, so we have some overlap. And then we have this light blue box up here, which are heterozygotes, and those are fish that are also probably caught during a period of time of year when it's a little bit in the middle, right, for these fish. But the main point is our summer steelhead show this GREB1L, and I think that's red or whatever color gene. And so now we can look at, okay, what do we see pre-dam? We have AD, ID, and BD. AD is after dam removal, above dams. ID is in between the dams, and BD is below the dams. But the main point here is let's look at what was above the dams pre-dam. Is we had all of that summer steelhead gene, and those were all found in resident rainbow trout. And then after dam removal, we've got that number has diminished. But what you see is that the number of that summer steel, the proportion of the summer steelhead genotype that we're seeing is now starting to show up at a higher rate in the below dam area. And so that just means that we're catching adults that were generated by rainbow trout, right? That rainbow trout played a very important role because pre-dam, we did not have any genotypes for the summer steelhead, right? Below the dams. They just didn't exist. And so they only started to show up after dam removal. So I think, again, this just highlights that dam removal isn't just about rebuilding abundance. It's about rebuilding diversity in life histories. I mean, this is as cool to me as trying to bring back a woolly mammoth to life, right? You know, Eleanor Chittenden was one of the last people probably to see some of these true wild summer runs almost 100 years ago. So in summary, steelhead keep moving up, further upstream each year. They've kind of almost reached a peak. The summer runs are now over 20 miles above glines. They've really penetrated those headwaters. Coho, they're really broadly distributed, but this really isn't a big Coho river. But nonetheless, we're seeing juveniles move around the watershed a lot and fill in certain places. And the Chinook are moving far upstream, also like steelhead. The natural production has begun to ramp up since the river has stabilized. And I guess we also have some questions about other species, such as Pacific lamprey. So they were making it right through there as soon as the dams were out. And if I had any guess now, lamprey are probably the most abundant anadromous fish that we have in the Elwha that are being naturally produced. And then bull trout, it's another cool story. Very scarce, very small in size, below dam removal, before dam removal, down below the dams. But the bull trout that were trapped above the dams immediately resumed anadromy. It's increased their size because they've gotten older in age and their condition has gotten better. So that's really helped the bull trout. And last but not least, one of my favorite birds in the world is, what have these anadromous fish done to the dipper? Well, some pretty cool stuff. It didn't do much for the males, right, which is to be expected because sperm is cheap and eggs are costly. But what you see here is that this is a mass index, right, for each of these birds. And so you can see that females without anadromous fish had a significantly lower body mass index than those that were exposed to anadromous fish. And these measurements were taken out of Little River before and after the river was opened up for anadromy. So one of the things that we saw were the dippers just going crazy, right? There were so many eggs and so much flesh for them to eat that it was just, glorious to them. It seemed like to me, it looked like a little slice of Alaska. So in closing, that's it. Thank you very much. And if there's any questions, feel free to let me know.
Okay, well, rather than use chat, why don't you guys in Zoom that want to ask questions unmute yourself, and our mic is open here in the room, and so we'll just let people in the room ask questions as well, one at a time. Anybody have questions?
Yeah, I do. Hey, John, what happens when hatchery fish returns and mates with a wild fish? Do the offspring match the behavior of the wild or the hatchery fish? Is there a...
Yeah, it depends on the species, but universally they just do not survive as well. So you don't, it depends. Summer steelhead, we tend to see more introgression for some reason than we do in winter runs with hatchery fish. But generally it looks like the most common outcome is at least with stocks that are, should be clear because there's kind of two types of hatchery programs, right? There's these kind of old traditional programs that run Alcee stock, the Skamania stock. Those fish, their survival in nature is 10-20%, right? So when they breed with a wild fish, the genes just basically disappear from the population. And when you start getting into brood stock and these other things that derived at some point, more recently from wild fish or used wild fish, it still looks like survival is really pretty poor. It's not as low and it varies, but they don't survive as well and they don't have the same, they're an intermediate to a hatchery in a wild. And that's probably why they don't survive as well, right? As one animal has been selected to do really well in a hatchery and the other in nature and that mismatch inevitably results in, you know, poor survival for the hybrid between the two. Not always, right? I mean, there are some cases where, but generally on average, their survival is lower, and it can be anywhere from, you know, 5 to 10% at a small level up to, you know, 60 to 70 to 80%. It depends kind of on the study and on how they measured it.
Other questions in the room? So, John, do you think your results were unique to the river, or would these be typical kinds of results you would see on any dam removal, or what was unique about the river?
Well, you know, we are opening access to basically what is untouched habitat, right? So that's different. You know, I live in a place where we literally do, you know, this is one of the Olympic National Park is one of the very last truly untouched places in the lower 48. You know, people can say that there are national parks in California, there's some around in different places, but this has not been inhabited by Europeans for very long, right? And none of this doesn't have a, you know, it's different. So the pristine habitat makes a difference, right? I think that makes a difference. But otherwise, to me, it's to be expected. I would have expected a rapid response and a good one. All the papers that I've read on dam removal for steelhead and other salmon show pretty rapid responses of the fish to the improved access to these headwater habitats. And for me, that's why removing the Snake River is so, you know, those snake dams is so important, because there's no way with climate change and the pace it's moving that those fish are going to persist in the Columbia being as warm as it is. And it has nothing really to do even with the warm temperature itself. It's just that we've literally filling up the Columbia with a bunch of exotic species that I could give two rats about, right? I hate walleye and I hate bass. You know, I don't want any of them in there, right? People want those, and go back to the Midwest and catch them. So part of the concept of breaching dams is you recreate habitat that favored salmon and does not favor those other fish. I mean, there's only one reason we have pike minnow in the Columbia that exceed 24 inches. It's because it's a bunch of stagnant water, right? If you cranked up the velocity in the mainstem Columbia and Snake River, those fish are all going to be pushed to the margins and edges like they were historically. So I go back to, I think dam removal is critical, right? That we need free flowing rivers. I also think the hydropower is, I hate to say it, but it's old news and it's not clean power. And we have so many other great options for power right now than hydropower. But I understand it's a challenge, but nonetheless, I think the snake dams, they absolutely have to come out, you know, if we want those fish to persist into the future. And if we want to give, you know, tribal or recreational anglers a chance to be fishing for those fish in 50 years. So I do think dam removal is important. I think the Elwha is a bit unique because we have really pristine habitat. But that said, I think, you know, places in the Snake are, it's not totally pristine, but you're still providing access to a lot of relatively intact habitat, and it's habitat that is predicted to be a refuge for cold water fish as the climate warms. So I'm excited about dam removal. I'm excited to see what happens in the Klamath. I think it's going to be another success. And it shouldn't be surprising because all of these fish have basically evolved to live with this stuff throughout their evolutionary history, right? This is their trick. Salmon have evolved through volcanism, glaciation, huge floods, forest fires, drought. You know, when glaciation was at its peak, it's likely that, you know, Mexico was full of steelhead. So we have to think about that at times. There are rivers that drain to Mazatlan that their headwaters have large, relatively robust populations of native trout that were related to old cutthroat and steelhead. So the distribution of steelhead and salmon at this point in time is different from what it was, you know, for much of their history. So I think they're uniquely adapted to dealing with these short-term challenges and environmental difficulties, which is why I'm excited to see the Klamath and hopefully, you know, the snake come out in my lifetime.
Well, John, if dam removal is one of the answers, we have a number of coastal streams that are not dammed, and yet the salmon and steelhead population on those are drastically low. I mean, I understand dam removal is one part of the picture, but you know, you have the ocean conditions and everything else. So why don't we see a big improvement in the salmon and steelhead numbers on our undammed coastal streams?
I think that's pretty clear, Tim, is we're fishing the crap out of them and we're playing hatchery fish all over them, right? I mean, this is the difference, is that there's no way you're going to recover salmon or steelhead, wild ones at least, fishing at the level that we fish at, right? I mean, it's absolutely impossible. And all my friends that are modelers can generate you a stock recruit curve and say that they can harvest this, but everywhere we've applied our fishery models, everything's gone down the crapper, right? So, I mean, yeah, you know, not fishing, right, makes a huge difference. That allows fish to rebuild diversity, spatial distribution, other attributes they don't have. So I go back to, but I would also say that, you know, you go back to all of, when we think of why the salmon are depleted, it's not like as simple as ocean conditions. And there's a number of reasons I can give you that. For example, we know that the size of the fish, the size of the steelhead smolt, for example, determines its survival rate when it enters the saltwater. What we don't know is if our smolts are now smaller than they used to be historically because there's less food in our systems. So we don't know whether ocean survival has declined because of things that we've done to the fish themselves, or it's truly because ocean conditions have fallen apart, right? We don't have data going back to the 1940s that's going to tell us about ocean productivity. So we get a very simple, palatable description of this, generally from the media and most scientists, but it's more complex. And I think anytime you look at where we have strongholds, where fish are doing really well, generally they have high quality habitat or higher, their fisheries are better managed, right? And they have fewer hatchery fish. And I would give you Oregon Coast Coho as a great example. You know, Oregon Coast Coho were completely down in the crapper, and they spent tens of millions of dollars trying to restore the habitat, and the habitat restoration didn't work. So they reduced the ocean harvest by 75%, and they dramatically reduced the hatcheries by even more. And, you know, in the mid 2010s, you had numbers of wild coho that returned to the Oregon coast that you hadn't seen since the 1950s. So you show me another river where you've taken that kind of action. You know, these are the actions, big, bold actions are what these fish need. And I looked at places too, like the Middle Columbia, you know, where it's doing pretty well, right? And the Middle Columbia steelhead, for some reason, are surviving at much higher rates. And one option is it's the place with the fewest amount of hatchery steelhead in the entire Columbia. So we talk about these things as like, there are some really pretty clear patterns where we've done well and where we haven't. So I guess I would say that dam removal works, but in and of itself, you could protect the best habitat in the world and you're not going to have any fish. We could look to Alaska. The decline in all the kings in Alaska, look, that's because they've been over harvesting immature Chinook for over 150 years. And so places are closing in Alaska. I think the Yukon fishery closed this year, nothing to do with habitat. And it's not because the ocean has gotten any worse. I wouldn't doubt that it has, but it's because we're shrinking the size of king salmon, and every species has an evolutionary calling card that makes them unique, that makes them successful. Like if you're Kobe Bryant, it's a turnaround jumper like Michael Jordan had. Nobody could stop it, right? If you're Shaq, it's a dunk. If it's Tim Duncan, you can make your free throws and rebound. For Chinook, it's about being big. You've got to be 50 to 100 pounds. If you're 10 to 20 pounds, you're basically a coho salmon, glorified, right? For steelhead, you've got to have a lot of repeat spawning, a lot of rainbow trout, and a lot of diversity. Coho salmon, beaver ponds, and low gradient habitat. But my point is that every species has something they require. And the more we take away from each of those fish, each of them has a different solution because they each have a different problem that they face. So I hope that's a long-winded way of saying that one of the reasons we're seeing what we're seeing in the Elwha is because we're not fishing. You know, we've allowed the fish to do what they want, and our trajectories and runs are changing, are not coinciding with what we see in all our other nearby rivers that we are fishing. So I think it, again, highlights how important it is to better manage our fisheries and our hatchery programs.
John, I have a question. Oh, no.
Yeah, Shandy.
Oh, the tags that the steelhead or that you guys are using on steelhead up on the Elwha, you said they're radio tags? Or are they just
Some are. So
so
not into the ocean, but once they
see, why do we not track them when they're out back to sea?
Well, we're starting to, mainly because it's been tech limited, is that they haven't had the technology, because these transmitters require batteries. And so you're hoping to find one fish out in the ocean for and you can't get a battery that will run long enough on that small, and then you've got to actually have receivers out in the ocean frequently enough. So it's only been relatively recently that we've been looking at it more in detail. But that said, we have like literally 80 years of harvest data. We know where all the steelhead are in the open ocean because of all the net data. They're not netted very frequently. They're not caught that much, but we know where they're going, and kind of, we don't know where individual stocks are going in any given point in time, but we do have general sense of, like our fish in the north go out further into the North Pacific than fish from where you folks are at, right? And as you get down into southern Oregon and California, a lot of those fish don't even head off the continental shelf. So there's different migrations, but they have very strict temperature limits. And this is the concern that I have overall over the course of the next 50 years. I mean, I think conservative climate change models now predict a 2-foot sea level rise by 2050, right? So what is that? 28 years, 2 feet. It's going to be more than that, right? It's probably going to be 5, 6, right? Scientists underpredict this stuff. There's massive glaciers. We're not accounting for all the fossil methane. The concern that I would have, and to me this is serious, is that, look, we're going to increase the ocean level so much that it's just going to make it a really warm, soupy mess, and probably more acidic. So you can see over evolutionary period, we've got climate data for temperature going back, estimates going back 300 million years. And we can see over that 300 million year period, there's this very narrow 5 million year period very recently when salmon evolved and the ocean actually got cold enough for us to have salmon. Now, fortunately, steelhead are pretty thermally tolerant, so they do better in a warmer ocean than a lot of these other fish. But yeah, it's like, T-minus 2050, because if our sea level is truly 2 feet higher in 2000, it just seems like the water chemistry changes will be so great. So that worries me about our ocean migration, which means, Chandy, in short, you might be catching lots of half pounders after 2050 if we don't get our act together as humans. Because I think that's what we'll have.
So the migration, say for like Olympic Peninsula, BC, are they doing are they heading to Japan kind of and doing that migration, that jet stream? Or?
Well, it depends. So the difference, how far a fish goes in the open ocean depends on how old it will mature. So one reason that Southern Oregon and Northern California, at least, there's more smaller fish than we have. Now, your winter runs tend to be bigger, but summer runs. So that's not always the way it was, but small, if a fish is 4 pounds, it is a 1-year-old probably. So a 1-year-old wouldn't have as much time to migrate or energy to migrate out as far as a 2-year-old. And so there's basically loops, right? A 1-year-old goes that far and comes back, and a 2-year-old is a little bit further, and then a 3-year-old is even further. And then the 4s and 5s, the very rare, the huge fish are way out there. But what we see is that for our steelhead, basically from the Columbia River north, they don't spend any time on the continental shelf like salmon do. They immediately shoot off the continental shelf and go to the high seas. And then they're out there, and, it's unlikely that our 1- and 2-year-olds are going out that far, but we got 3 and 4s. They're probably going out to the Bering Sea, off the Aleutian Islands, Kamchatka Peninsula, stuff
and
like that.
Pelagic, are they going super deep, or are they pretty subsurface?
No, they have to be almost at the surface, because steelhead are a very old salmonid, and all the ancient salmonids were resident first. They weren't, anadromy, and being able to go to the ocean is recent, right? Really recent for salmon. And that's how we got all these different species, like coho, chinook, sockeye. They're all young. Like steelhead, cutthroat, bull trout, they're old. Whitefish are old. You know, whitefish are, I mean, that's, you know, they're old salmonid, right? So all the oldest ones are resident. So steelhead have a very limited ability to withstand the higher salinities that salmon like chinook and coho do. So they have to stay in the upper 15 meters of the water column in the open ocean.
Interesting.
Almost universally. Yeah. They're in the upper 15 meters.
That's really interesting.
So you said you've recently changed positions, jobs. Are you going to be
Yeah.
Are you going to be snorkeling fish on the Elwha anymore? Or are you going to be just mostly in the courtroom?
Oh yeah. No, Elwha for sure, but there'll probably be some more litigation out of me now. I've you know, look, I've watched my dad do and everybody else, you know what I mean? It's just the agencies have had their chance, right? And it's universally almost failed, considering where we're at and what we're about to go through. So yeah. Look, if you look at the animals that we've recovered, they all required substantial litigation. Peregrine falcon, bald eagle, you know, you go through the whooping crane, you go through all this stuff. It takes a lot to save an animal, right? To kind of get us out of our own way at times. And not meaning all of us here as individuals, right? I mean, we're all, but you know, it's hard. And my job is, I don't think I can save every population. Again, I'm just really focused on, you know, the very last best places that I want to leave something behind. I'm not worried about those that are at the end of the bench that are already kind of destroyed and don't have much chance to me at a realistic recovery. I'm talking about the last 10, 12 best steelhead rivers we have in the lower 48.
What
there's
rivers
still a lot
do
of science, you know. Which ones do I think? Are the
yeah,
best?
where do you like to go look at fish?
Well, I don't travel much, right? I mean, unless I have to. So I live most of my life up here on the OP, which is where I'm at, or I go to, you know, BC up on the island. But I've been throughout pretty much I've been in every steelhead watershed in the lower 48. I've swam in probably 80% of them, but I like my rivers up here on the OP. Yeah.
So
we all have our favorites, right? I mean, it's just the way it is.
So are you involved at all with the BC steelhead stuff? Because that sounds pretty tragic right now.
The what? Well, I'm familiar with it. The BC, the decline.
Yeah. Because it sounds
yeah,
like
that is tough. I mean,
because they had a good thing going there for up until 15 years ago or something, and now they've really gone backwards.
In the Thompson or the
yeah, Fraser in that area, yeah.
Yeah, I think, you know, the Thompson, I mean, it's been happening, you know, there's work coming out suggesting that the most likely explanation for a big decline in steelhead range-wide last year was not just the change in ocean currents that are happening, but there are so many hatchery pink salmon that we're planting in the North Pacific that we're swamping the area with food. And the Thompson River steelhead have been very tightly correlated, their demise, with the planting of these pink salmon. And pink salmon are pretty easy to determine their effect because they're odd even year fish, right? So you can pick their signal out really clearly. In fact, we're showing that Alaska is releasing like over 1 billion of these things. They're negatively affecting the size of Chinook and size and survival of Chinook and Puget Sound and the Columbia. So they're correlated with the decline of Thompson steelhead. But it looks, what has happened in the Thompson is that some combination of that combined with the fact that they've been bycatching those steelhead at very high rates in commercial salmon fisheries throughout the main stem Fraser, and Canada never addressed it. But Canada, you know, BC and the provincial, you know, even the Canadian government, just, they won't do what's right, right? There are some good people there, but the federal Canadian government, DFO is a problem. So I think Thompson steelhead are done for.
John, can you tell us how you keep your chin up in these times? What kind of, I mean, I personally know what you've done on social media. What keeps you moving forward, positive motion?
You know, places like the Elwha, but I've also lived through this, and my family's been out here for, since the late 1800s, and so they've seen the good and the bad. You live through the good and the bad. I mean, in the mid 90s, the crash that we had in the Columbia for steelhead was just as dramatic. That was the time when Larry Schoenborg started to go out of business. Kaufman's fly shop started to struggle. I've been through this before, and so that's part of it, right? If you've been through it before, you expect a turnaround, which will happen. Although I think we're running out of time on that in the long haul. The second reason is places like the Elwha. Look, we know how to get ourselves out of this mess. It's really clear. We have places that are successful. We've got to manage our fisheries better, right? It comes down to it so often that we're investing millions of dollars in habitat. The runs are getting worse. We refuse to address our fisheries and hatchery production. And so we continue to operate like that. Unless we're going to turn those dials in a big way, I think we're probably going to stay in the same place. But I would also say that I'm a fighter. I grew up in a little town, and I worked at a pulp mill, and I enjoy the fight, right? Like, yeah, there's, Muhammad Ali doesn't step in the ring because he doesn't like to fight. I enjoy the debates that take place here. And I feel that, I want to change something and leave something better for the future. So even though I might have to make some sacrifices now, more than willing to do that. It fits my personality to be in a fight at times. So I would say this though, look, salmonids are not going to go extinct. You're always going to have trout or something in fresh water. These fish will always persist there. But it is worrisome, right? I'm not sure that you're talking 20, 70, or 80 that there are any more. You know what I mean? I don't know that we're fishing for salmon anymore. It'll be
Bad my whole life.
by 2080, if we're not fishing for salmon, that'll be the least of our problems because, look, yeah, we're completely unprepared as a civilization, right, to deal with 5 to 10 feet level of sea rise and all the stuff that comes with it. So. And the cool thing is, the most hopeful thing of all is that when they originally started modeling the effects of climate change back in the early 80s and late 70s, it was actually before that, but some of the first complex models, and this looks like it could unfold, we're only going to be in a warm spot for a short period of time. It's going to revert back to an ice age probably pretty quickly into this, like a full-on, everybody's seen that movie, but that's the real. As we disrupt these currents and we get too much fresh water on top of the salt water, it disrupts the conveyor belt and the upwelling and downwelling and circulation. And most people aren't aware that like a place like Great Britain and, New York City are really high latitudes. And the only reason that they're really habitable for long period, they'd be much more like Norway, right? If we didn't have those circulation systems. So I think that I always go back to that, Shandy, we just eat because literally, the science looks so terrible for humans in 50 years that fish will be fine in 150 after we've done whatever we've done to ourselves and it starts to cool off again. That's kind of my opinion on it. So I keep some hope that nature bats last, nature will always bat last.
I think we lost him in the room, it sounds like. So it's just, I think it's the Zoom people that are left. So technology on our side has won. Does anyone have any more questions for John?
Too many.
Anyone?
Enjoyed the presentation quite a bit, though. I'll tell you that. Did a good job.
John, can you let everyone, we'll put a hyperlink for your Instagram account, but
oh yeah, rainforest_steel is my Instagram if you all are on there. And over the course of the next year, I'm going to be explaining some more of this stuff to folks that are interested. Like I've walked people through a lot of this before. And sometimes the things I say may come as a surprise because, look, I love this, right? This is my entire life. I spend all my time either, swimming, fishing, or reading or, conducting research. And so you know, it's fun to share it, but I also understand that most of the time that folks get their information, it comes in a way that's filtered such that, you know, it's all the ocean or it's all this or there's, you know, and it's not, it's just really, truly much more complex than it's often given credit for. But at the same time, it is also that simple that they just need good habitat. We can't kill too many of them. They need their diversity. And if we do those things to allow these fish to persist, I think that we can continue to have fisheries. And so I'm convinced, you know, that we're going to keep working, put the shoulder to the wheel, and, you know, hopefully kids in 20 or 30 years have another chance to fish with these fish.
That's right. For our members who have grandchildren or adult children, really have a look at John's Instagram account because he makes learning super entertaining. His analogies are really easy in layman's terms, and just some really beautiful photography and videography. It's definitely well worth sharing with your friends and family, especially the young ones. Super fun.
Thank you, Shandy. And I do want to say that that's my constituency, right? Like, it's the grandkids, man. I'm not doing this for me to fish, or frankly, any of us that are sitting here right now, right? I mean, I assume if we all got together, we'd have a great time with a beer and some good food. And that doesn't mean I appreciate it, but I felt like fish helped me get through so much in life. And I want other kids to have that opportunity, you know, to experience nature and feel like, you know, they love something that much.
Absolutely. All right, guys, should we let John go to bed?
Thank you very much.
So.
Thank
Yeah,
you
that
so
was
much.
awesome.
Thank
Appreciate
you,
it.
John.
Yeah, thanks, John.
Yeah, that was awesome.
Yeah, thank you very much. Thank you very much. And yeah, hopefully we'll have, oh, and if you all folks want to see, we made a video. I'll send a link to Shandy and Tim because we have a video, you know, on the Elwha summer steelhead up there. I'll send a link to some research papers to Shandy and Tim also that we just published on the Elwha for anybody that wants to look at them.
That'd be cool. And I'll also do the link for Shane Anderson's film as well, so that, you know, there's just so much cool stuff to watch and to get a better gist, better look. But thank you.
Yeah.
Can't
Well, thank
wait
you.
for
And it's great to meet everyone.
get to Russia.
Yeah.
Can't wait for updates eventually.
Thank you, everyone.
All right. Good night. Thanks,
Good night.
everyone.
Bye-bye.
Bye.